SQL injection attacks. Simple yet powerful. The SQL injection attack is extremely useful since it gives you unparalleled access to the database. Hello Internet, I'm Arya Bagheri and today we'll cover how SQL injection attacks work, how to defend against it, and at last I'll show you how I use it to bypass logins and delete logs to hide my tracks. So SQL injection attack is a type of injection attack that works with SQL scripts. SQL is a language used by most database engines. While there are minor changes between each engine, the SQL language stays the same for the most part. For those that haven't watched my video on injection attacks, look down in the description. So an injection attack is basically when you place a piece of code inside another piece of code provided by the application itself, better known as the template. The app intended for you to put a password in the field, but then when you put an SQL exploit, the database engine can't tell the real part and the hostile part apart, so your exploit would run as well. Now, this exploit could do lots of different things, elevating your access, deleting records, and so on. Before we perform the attack, let's talk about the techniques used to defend against it. Using prepared statements with parameterized queries help stop this attack at its tracks. Parameterized queries help the engine distinguish SQL code and user input. The only downside to this defense is that it might actually hurt the performance a bit. If that's a deal breaker, you can go with heavily sanitizing user input. With this approach, you first give all the SQL instructions to the engine, hence the prepared part, then supply parameters one at a time. This is actually how you should learn to write database queries in the first place. The second defense method is using stored procedures. Stored procedures are personally my go-to, along with parameterized queries. They offer superb performance and optimization. Moreover, I found that unfortunately people that work on my projects have been less than careful with security. With this approach, you just write an awesome and efficient SQL query once, then whoever wants to use the query can just send the parameters over instead of repeatedly rewriting the same SQL query. For more flexibility, I sometimes store my procedures in a separate folder within the source code, but they can also be saved in the database as well, which is a good thing. With this design, instead of the programmer writing the query to fetch products every time, they just call a fetch product function and supply the inputs. This way, since your queries are pre-made, they can be heavily optimized by your database engineers and super safe since amateur programmers can't touch them. The third defense strategy is about standardizing user inputs. Strings are the enemy. So if you absolutely have to use strings, you can convert them to other data types first. For example, if the ascending and descending order is supplied by the user, the best case scenario is to input an isAscending Boolean value. This makes the request lighter and increases performance, as well as making it impossible to inject anything. If your design does not allow that for some reason, you can convert the string to Boolean and then back to the string again in the backend. It is impossible to inject SQL scripts through integers, so basically any data type other than strings could perfectly sanitize your user inputs. The fourth defense strategy, which is also a method of last resort in this case, requires input sanitization. I usually do this on the client side for the data supplied by the server to protect users against XSS attacks. This way, even if the hacker has full access to my database, the clients stay safe from XSS attacks. This technique does affect performance a tiny bit, but it is most certainly worth it in my opinion. Input sanitization basically replaces characters that might be mistaken for code, so the database engine doesn't get confused. For example, a space can be replaced with another character or even multiple characters like percentage and 20. Please note that these defense strategies are mostly for the server. The client app can be bypassed completely in most cases. When securing an infrastructure, you have to first make sure the server is safe. Then assume the server is breached and try to make sure the client is safe. This way you can provide your users with maximum security. We will cover these techniques in our secure labs, where we show you how a vulnerability can be exploited and how to fix the code to completely obliterate the vulnerabilities. For now, I'll just demonstrate the attacks and not get into the fixes just yet. In the injection attacks video, I already showed you how to exploit our bypass authentication lab level 1. Now we will dig deeper in that example to show you how you can retrieve the original password as well as bypassing the authentication. Then we will go into our non-input lab to learn how to inject SQL even if the user inputs are heavily protected. At last, we will remove any evidence of us trying to log in and bypass the authentication. Disclaimer: I'm not recommending you to use any of these techniques illegally. This is just to show you how you'd approach testing the infrastructure that you are allowed to test. So in the first lab, we can see a pretty standard login form. We have a username and a password field. Now let's check our database tab. As always, we are using Next.js and PostgreSQL, both being top-notch technologies that I absolutely love. Here we can see all the usernames and passwords. Usually, you'd see usernames and password hashes. But since this is level 1, we have plain text passwords. So if I grab an email from the database and put the right password in the password field, I can see that the login form works. Now, anything else I put as password does not let me in. So this part works as expected as well. Now the question that we have is there anything else I can put here other than the actual password that would give me access? This is where SQL Injection comes to rescue. So if I write a close quote, or 1 equals 1, a semicolon, and 2 dashes, I can log in no problem. This exploit has a flaw that we will get into a bit later. To understand how this magically solved our problem and allow us to bypass authentication, we have to look at our SQL queries. As you can see, I have select everything from users, where the username equals the inputted username and password equals the inputted password. So when I place a normal password, it makes sense to the engine. Now when I place the password in, you can see the password field gets empty. And we have an or 1 equals 1, which is always true. Then the semicolon tells the engine that we are done with our command. And the double dashes turn the additional quote into comment, so it would be ineffective. You can see how I just changed the logic without having access to the backend and injected my own logic here, which is something I shouldn't have been able to do. Now, this exploit has a flaw. It only works for the first row in the database. That's because when we put the or 1 equals 1, we disabled the email check. So now all the users will get returned, and the server sends us the first one. So we can put anything in the username field and still get the same account. Now to solve this, we are just gonna write or email equals quote and then our target email address. Notice that we don't close the quote on our email address. This is because the server is going to close that code for us. So now we can access whatever account that we want to. Sounds good, right? To go even one step further, we can retrieve the original password by just going to our DevTools, then Networks, and then seeing the server response. As you can see, here we have the password that we can now use to get more access in areas that are heavily protected. A chain is only as strong as its weakest link. That's why, if you include code like this in your page, it doesn't matter how secure the rest of the application is, your website becomes extremely insecure. Now it's time for our second lab. As you can see, we have a list of randomly generated products spread across multiple pages. Now, you might be wondering, how am I gonna inject something here when there is no user input? The truth is that user inputs are not the only way to inject SQL into the server. We can use things like pagination, pre-made filters, and even IP address trackers to inject our scripts. So I would go to our DevTools and Networks tab to see what my app does when I go to the next page. Here I can see that we have a call to the getProducts endpoint. The payload contains an offset parameter. In SQL, we use the offset and limit to provide pagination. Select everything from products, order by created at descending, limit 5, offset 0 for the first page. Then offset becomes 5 for the second page, and so on until this returns empty. In this query, we are first sorting everything to get the latest products first, then limiting it to get 5 at a time. It basically works like this. Go 10 rows down, then give me the next 5 rows. Now if we supply a string offset, if the server is not standardizing the data properly, the string is going to get injected. So if you supply an offset 0, followed by a semicolon to tell the engine you are now supplying another query, and truncate table logs, then all the logs will completely disappear. So the system admins would have a harder time trying to figure out who did this. If you're being smart, you can, instead of truncating, write a delete command that targets all of the logs that have your IP address in them. So this way, the logs are there, and the forensics team would have a hard time analyzing the logs, looking for evidence, since you just destroyed it. So this is it for this video. I hope you enjoyed it. For more videos like this, subscribe. I put many resources like this on my YouTube channel and my personal website, so definitely take advantage of those resources. Stay paranoid, stay alive.